Right. Continue. Where is this girl? Ashmi saying that Anand also missing today. Anand, I think he's taking a break because taking his exam like it's also. Most of the students' exams are going on. Like Anand's exam is done, I think he is taking a break from study. So his exams ended today. And the two girls, the sister. So that's a regular thing in today's generation. Everybody takes a break after exam for a day or two. But what I don't take break classes. Actually, I mean, not required. You guys are so small still that there's junior classes. I mean, I can understand if it is that one. Okay, but where did we stop last class? Wavelengths. So we were doing terms associated with waves. Okay. We have to still do characteristics of sound, right? We discussed frequency, time period, amplitude, wavelength and speed of wave to be discussed, right? Yeah. Okay. Wavelength discussed. Only the definition is clear. Like this is the sound wave. And this is, let us say, displacement. So this could be pressure, density, or displacement. And if this is time, so this could be x, could be t also, right? Displacement or time. This is also, if you take the displacement, then this is plus a maximum displacement this side. Likewise, we have this and minus a. So one is pressure, density. Also, it can be like the displacement from the mean position. So this is the mean position here for the transverse wave. For longitudinal wave, the displacement is horizontal, parallel. And this is also the direction of velocity. E is the direction of wave, right? So I've told you this. So what is wavelength? Wavelength is this distance, one cycle. Okay, the distance traveled by the wave or the. So this is the distance traveled by the wave from here to here, go to this place. Okay, this is one wavelength. Okay, so it is the distance traveled by the wave in one time period. How much time it has taken? T. So if x is lambda, then t will be the time period. Okay, this is how wavelength is defined. Distance traveled by the wave during one oscillation. So look at lambda and time constant. Lambda is the distance traveled in time, capital T. Okay, so they are related. Like, what is oscillating? Particles are everywhere, right? Particles are everywhere. Particles are everywhere. So let's say there are particles everywhere. Okay.
Again. So when this particle began its vibration, this was not oscillating, right? So when it goes from here to here to here, this is one vibration, one cycle. Now the disturbance in the meantime travels from here till this particle. Understood? When it goes up, first this will be disturbed, then this, then this, then this. So the disturbance has traveled here. Let us say when you reach here, then the disturbance has only disturbed this part, this particle, till here. When it came back, then the disturbance has reached here. No, here. When the object comes back to the main position till here, when it reaches here, it has reached here. Again, when it comes here, it has reached here. Understood? So the wavelength is the distance traveled by the disturbance during one oscillation of the particle. Understood? Yeah. So wavelength is the disturbance is nothing but the wave, right? Yes. The distance traveled by the wave. One oscillation of the, so whatever time it takes for one oscillation is time period. Okay. Of the particle. Or time. So during the duration of one oscillation is time period. Whatever distance the wave. And the next characteristic says, what is this number? Serial number? What is it? Serial number? Serial 3, 4. This is 4. 4. So now fifth. Velocity. What is velocity V? Velocity is distance upon time. Yes. We know that when the distance traveled is lambda, time is capital T. So lambda 1. Yes. Okay. It is the rate with which the wave has disturbance travels. So wave को travel की वजह propagate speed होता है. Disturbance propagates or propagates. Through the medium. For unit time. Okay. Yes. So we know that lambda distance is traveled in time t. So the distance traveled per unit time will be lambda by t. And 1 by t is frequency. We know this. Well, even in the definition of frequency. Frequency. What is it? It is the number of oscillations in one cycle. This nu is equal to 1 by t. Given because T corresponds to one oscillation. T second corresponds to one oscillation. 1 second corresponds to 1 by T, which is frequency. So 1 by T is frequency. Okay. So this is the formula for wave velocity. That's it. Yeah. Why it is so? Because since mu equal to 1 by
Lambda does not have a fixed value, right? Lambda does not have a fixed value, right?
no. Does not have a fixed value for what?
Uh, um, like it does not have a fixed value as in a number or anything.
For a given wave, it has. If it doesn't have a fixed value, then how it can characterize?
Like universally.
No, no. Everybody's wavelength and frequency will be, every sound may have different wavelength, but the sound has to be different. It should be originating from different sources. Okay. It may originate from the same source also, but may have different frequency and wavelength. That is possible. But this we have covered all the terms associated. So let's do this example 1. So what is given in example 1? What is given to you is you have a sound wave, and its frequency given is 2 kilohertz. And also wavelength given is how much? 35 centimeter. How long it will take to travel a distance of 1.5 kilometer? The distance of 1.5 kilometer. You are supposed to find the time duration this wave will take. How much time the wave will take, right? To travel the distance of 1.5 kilometers. So we know that V is equal to distance upon time.
It's
So this gives us P is equal to distance upon velocity. Right? Velocity of sound wave is given by frequency into lambda.
oh,
This is the velocity of the sound wave, right? Because velocity of the sound wave is not given. What is given is frequency and its lambda. So what is the distance now? 1.5 kilometer. Converted into meter. Frequency is 2000 hertz. Now, hertz can be written as per second. What is the unit of frequency? 1 by T. So unit of frequency is per second. And lambda is again meter. How many lambda? What is lambda? 35 centimeter. It will be 0.35 meter. So meter gets cancelled. Second will go up. So what is it now? If we promote this, then you have infrared. This is 150 divided by 70. So it is 2.5 seconds. Is it 2.5 seconds? No. 7 to the 40, 2.1 seconds. What is the answer? Ah. Okay. So you have to read the question carefully and accordingly you have to solve. Next is characteristics of sound. So there are three characteristics. So you're writing, right. Done. So why do we need characteristics? What is this one?
AC.
Well, this one.
Uh,
We need that. History. So B1 there is an B1. The last two you require. This is okay. Okay, what are the characteristics of sound? So characteristics of sound is needed to differentiate among different sounds. How do you discriminate between two different sounds? Okay, using their characteristics. Uh, and, uh, needed. Differentiate. One sound. From others. Okay. Like any two sound wave will differ in their characteristics. So what are these characteristics? These characteristics are one is loudness, then you have pitch, then you have quality. Okay, loudness, pitch, and quality. quality. It is also called as timbre. Okay. So let us first understand what is loudness. So like when I'm speaking slowly, slowly means in a low tone, so it is not that loud. But if I raise my voice, then it becomes loud. But in both cases, student will come to know that I am only speaking. Okay. So what is different between not so loud voice and a loud voice? The difference is in the amplitude. Okay. So loudness depends on amplitude. For example, let's say sound one is like this. This is let's say sound one. Okay. So if you look at the amplitude, here the amplitude is 3, and here it is almost 2. So which sound is louder, S1 or S2? S2. S2 is a louder sound because its amplitude is 4. Okay. Now, who says that the sound is loud or not loud? The listener, correct? But whether the sound is loud or not will depend on the sensitivity of the ears of the listener. To some listener, a loud sound also may appear very feeble. Okay, it will not irritate. It may happen. So therefore, loudness is a very subjective property. Okay. So loudness is basically experience based, and that means it is not an objective property. Therefore, loudness is a subjective property. Loudness is a subjective property. It depends on as it depends on the hearing sensitivity. Or you can say it depends on the sensitivity. Ears of the listener. It depends on the sensitivity of the ears of the listener. Ear means eardrum. Basically, eardrum is the one that vibrates. Okay, eardrum. Okay, that's why it is a subjective property because it is experience based. Everybody's experience may be different. So it's not a correct prediction of the loudness. So then how can we measure the loudness? It is measured through its intensity. loudness of a given sound can be objectively measured in terms of the intensity of the sound. Okay. So every sound will have a unique intensity. So how do you define intensity? It is defined in terms of flow of energy per unit time through a unit perpendicular area. Okay. So intensity is measured in terms of energy. Energy flowing, let's say when I'm speaking, okay. When I'm speaking, the sound is reaching towards me. So there are various air molecules vibrating like this and transferring the disturbance and reach your eardrums. So you can think like 1 meter by 1 meter of area through which the sound energy is traveling. So amount of energy crossing the unit area per unit time. That's called intensity.
So area means the distance between the speaker and the speaker.
Area means area, length into breadth, perpendicular area
But area of what?
of the medium. I'm defining the unit area. Length 1 meter, breadth 1 meter. When I'm speaking like this, whatever sound energy, see, if somebody is sitting here, you will also listen. My sound is going everywhere. But I'm fixing the, let's say there is a squared pipe or a hollow pipe like this, whose cross-sectional area is 1 meter square. So unit area. So imagine there is a sound pipe. See, if it was a water, you have to have a pipe. But this can travel through air. So imagine there is an air tunnel. So the area of cross-section of that air tunnel. Which area? Perpendicular cross-section. Like this. For pen, the cross-section is the circle that you see. When you cut it, what do you get? Circle. So this, if it was hollow pipe, then also the cross-sectional area is the perpendicular surface. So the sound is traveling through each cross-section. So that cross-section is unit area. So in 1 second, how much of energy is flowing? That is intensity. समझ आया ना? Let us say this is a cross-section. So now I switch on the stop clock. Okay, the stop clock in 1 second, let us say it has 100 partition. So when I start watching it, and I stop the clock after 1 second, and whatever water is accumulated, that is the amount of water traveled. Okay, so likewise, amount of energy traveled in 1 second through this cross section will be given. That can be measured. So you know that energy upon time is what?
Energy of time is what?
Power. Energy and work is same. Work upon time is power. Okay. So in terms of intensity can also be defined in terms of power flowing per unit area. So what is the unit? Unit will be watt per meter square. This is the unit of energy.
What by base time?
The power का unit watt है, area का meter square. तो दोनों का मिला के क्या हो गया? Watt per meter square. Meter square.
intensity is used to measure the loudness.
Objective. Okay, so there has to be some relation of intensity to amplitude also, right? So the relation of intensity with amplitude is, it is directly proportional to the square of amplitude.
And I is in the intensity
Yes,
and A is amplitude.
amplitude. So this is the relation between intensity and amplitude. So bigger the amplitude, more will be the energy transferred per unit area per unit.
So the ability to recognize the voices is basically to differentiate someone's loudness, pitch, and quality.
Voice is same. Source is not changing here. Source changes, frequency changes. Like if there are two boys, you both may speak at the same amplitude, but yet your sound will be heard differently. Both may produce same amplitude, same intensity of sound, but still while hearing they will appear different because the frequency is different. I am only speaking with more energy. I am putting in more energy. Frequency is not changing. No. Is the frequency changing here? So the type of sound is characterized by pitch. Sound does not change here. Just the loudness is changing. So sound is different in terms of the loudness, not in terms of tone. Tone is same. Got it? So opposite of loud is soft, soft sound. So loud sound will have bigger amplitude. So soft sound will have smaller. So this is soft sound. This is loud. Clear? Now let us discuss the second characteristics, which is pitch. So what is the objective property? Intended.
Of pitch or loudness.
Loudness of a given sound can be objectively measured in terms of the intensity of sound. And I cannot be more clearer than this.
Blind universal pitch as
Pitch we are starting now.
he said that with the slide for pitch.
Pitch we are starting. So let us now understand what is pitch. Second is pitch. It depends on frequency of sound. Pitch depends on frequency. Sound of unique frequency is called tone.
Tone and pitch are different.
I mean, there could be two sounds of same frequency, but the tone might be different. Sound of unique frequency is called tone. Like a tone from guitar and a tone from sitar, although same frequency, will still you will hear them differently. Okay. Then
So tone is like the expression of the.
Technically, tone will have a sound of single frequency, but musical sound has sound from multiple instruments, so it will have a sound of mixed frequency. That is called note. Sound of mixed frequency. That is called note. Example. Musical note. You must have come across this term, musical note. The musical note will consist of an orchestra, many instruments playing together. Maybe at same frequency, different frequency, but it's a mixed resultant sound. Just like loudness, pitch is also a subjective property. Okay, depends on the sensitivity of the ears of the listener. Pitch is also a subjective property.
So how does a person be sensitive to sound? Like their eardrums are different.
So let us say an instrument is played. Some people are able to catch that, even if it is played, at certain frequency. And some ears will just not catch that frequency. It is being played, but you will not hear that. That's it. The frequency is not able to activate the eardrum of the listener. He will say, what is played? Nothing. He'll be puzzled. Whereas he will say, can't you listen? So that also is like sensitive. Some ears are, it's like color blindness. Just like that, there is a sound deafness also. To certain sound, some ears are not tuned to that.
So like what happens? The eardrums are some rigid sensitivity, right? They're born with it.
Yes, it's a defect. Maybe born with it, or they suffered some accident or some infection. There could be many causes. Right? So pitch is also subjective property. Now, so how do we measure pitch exactly? Okay. Frequency. The good thing is all sound can be electrically reproduced with the help of you can see the waves on the monitor, right? So there is an instrument called oscilloscope. Like every ICU patient's heartbeat is monitored.
Yes.
So heartbeat up. That is captured, shown as a wave. So all sound can be produced in the form of waves. Okay. And then once you have the time graph and X graph, then you can calculate, you can measure time. So from the time coordinate, you can see for one cycle how much time is taken. So the frequency is that. Okay. Whereas pitch of a given sound is objectively measured or expressed in terms of its frequency. So frequency is unique for a sound of a given pitch. So whenever I say subjective property, same thing. It depends on the sensitivity of the ears of the listener. So if I graphically want to see it, there you go. Let's say this is sound 1. So if you look at the amplitude, it is same. But here the frequency is not doubled. Can you see the time in which one cycle was completed? Now at the same time, 2 cycles are there. Okay. So this frequency is 1 cycle per second, let us say. This will become 2 cycles.
2 cycles per second.
Let us say this is frequency F. Then this will have frequency 2F. Double.
So the second sound will have the higher pitch. The second sound will have the higher pitch.
So this is obviously sound 2 will have high pitch. So this is low pitch. And this will have high pitch. So if you have you experienced low pitch, high pitch sound? Let's say between male and female. When both of them are speaking at the same level, let's say they are conversing, not shouting, they are normally speaking with each other. Then which sound will have low frequency? Male or female?
Male.
Male has low frequency. That's why male sound is flat. Okay. So male sound. Has low pitch. Female sound has high pitch. तो male sound कैसा लगता है? It sounds flat. Okay. And female sound shrill. Shrill will be very uncomforting. Like when females are shouting or fighting. So we can't stand that. Male don't shout that. So they will start fist. Start punching fists. Okay, so in the musical instrument, it's like so if you've seen the tabla. So this will have low pitch. This will have high pitch. Okay. So this will be like tan. So up.
So which is more perceivable delay?
Both are perceivable, but this will be like very sharp. This won't be that sharp. Like, are you familiar with guitar sounds? So the strings of guitars are thicker and thicker.
Yeah. Like
So which produces low note?
low notes would be the
Thin ones.
cases.
Sorry, the thickest. Thickest. And highest note is the thinnest. Okay. Same here. Depends on dimension. So the smaller dimension, the bigger frequency. So high pitch. Like when a singer also sings, no, like he may sing at different pitches. He may sing at a high note or a low note, right? So you can start low and go high. Like you can start like ऐसा करके तो you're going on increasing the frequency. That's all. Okay. So that is pitch. So both objective, subjective, we have covered it. What is subjective and what is objective in pitch? Pitch itself is objective, subjective. Pitch is subjective. Frequency is object. Yeah. Frequency can be measured from the wave. Any measurement can be done only on the waves. Okay, that's all. Last is quality or technology. So now here, in this case, both, in case of quality, both the amplitude and frequency may be same. Okay?
Yeah.
There may be sound with both frequency and amplitude same, yet they might be heard differently because of difference in quality. Okay? So quality of sound are differentiated on the basis of respective waveforms. So in this case, the amplitude and frequency. The amplitude and frequencies of the sounds may be same. Yet there will be heard differently. Due to difference sources. Okay, so two sounds are produced by different sources at the same amplitude and frequency. Yet they might be heard differently. इसका एग्जाम्पल देखो क्या है. यहाँ पे ऑब्जेक्टिव प्रॉपर्टी क्या हो गया उसका वेवफॉर्म. समझो हमारे पास दो साउंड है. S1 ऐसा है. Now see your amplitude is same. Right? And frequency is also same. Each vibration is completed in same duration. So both have same frequency also. Still, the sound will appear different. While hearing, it will be different because of difference in quality or waveforms. That's why when two people converse, a third person will be able to identify that who is speaking. In a family, two children, so parent will know who is speaking. Okay, both will know because qualities are different.
How does quality change?
Because of the dimension of the source. No two vocal cord will have same dimension. The sound produced, see, it's like composition. Good, right? This is also good. Is it same sound? So it's like depends on the material composition, dimension also. Now this is same wood, but here some slight difference will be. So the characteristics is also clear. So I think we have discussed on this. Next, what is remaining is reflection of sound and application. So next class, maybe we'll be able to finish it. Today, let me just give you a brief on speed of sounding different videos. Before, so speed of sound in air is 346 meters per second. Okay, and this is at normal temperature and pressure. Normal is room temperature, right? Then you have STP also, which is at 0 degree Celsius. Okay, standard and NTP, this is the difference. So as the temperature increases,
It is the full opportunity.
normal temperature and pressure,
STP.
standard temperature and pressure. So standard temperature is 0 degree Celsius, normal is 25 degree Celsius we take. Okay. So that's what it is. So basically speed of sound is maximum in solid. In the solid medium, the speed of sound is more than the speed of sound in liquid medium, than the speed of sound in gaseous medium. Okay, because speed of sound depends on elastic.
Because solids are more tightly packed, so disturbance travels quicker.
Very quickly, yes. Elasticity and density. So basically, you don't have the details of it. So and also it increases with temperature. So
Because of kinetic energy.
so basically, what is given here is speed of sound in different mediums. This table. So you can see that it is maximum in solids, then in liquid, and least in gaseous medium. Okay. Rest will cover in the next class. Somewhere you'll find this 344 meter per second also in your book only. Somewhere it is written 346, somewhere 334. So this is the problem, but okay. In one calculation we are going to use this. So I told you.